Okay, so with exponential expressions and equations, an exponential expression has the variable as the exponent of a power. So when we talk about an exponential expression, then you can have a variable raised to the power of a variable. You can have a number raised to the power of a variable. You can have another expression raised to the power of a variable. But as long as there is a variable in the exponent of the power, then it's an exponential expression. And with exponential expressions, we deal with exponential equations. Exponential equations rely on your understanding and recollection of the laws of exponents. Because they rely on what we refer to as the one-to-one property. The one-to-one property of exponential equations says if you have two exponential expressions with the same base set equal to each other, then their exponents must be equivalent. And so when you're working through exponential equations, you have to always keep in mind the laws of exponents that pertain to it. So just as a mini review, when you multiply two exponents together, two powers together, so I'm going to have a to the power of x times a to the power of y. When you multiply two powers together with the same base, you're going to add your exponents together. If you divide two powers with the same base, then you subtract their exponents. If you raise a power to another power, then you multiply the exponents. If you have a negative exponent, that means the reciprocal of that exponent. And any number raised to the zero power is equal to 1. So let's do some examples. So to start off, number 1, we have 5 to the negative 3a equals 1. Well, in order to use the one-to-one property, I need to have both sides of my equation have the same base in the power. So from my laws of exponents, I know that any number raised to the power of 0 is going to be 1. So I can rewrite this 1 as 5 to the 0 power. And using the one-to-one property, since I have two exponential expressions equal to each other with the same base, then that means their exponents must be equivalent. And then it just becomes an equation to be solved. So I'm going to divide both sides by negative 3 to get a is equal to 0. So as another example, I have 5 to the 3m power is equal to 125. So I need to rewrite this 25 as a power with a base of 5 in order to be able to solve this using the one-to-one property. So I have 5 to the 3m power is equal to 5 cubed. And so now that I have two powers equal to each other with the same base, I set my exponents equal to each other and solve for the variable. So I have 3m equals 3, which means m is equal to 1 when I divide both sides by 3. As another example, we have 4 to the negative 2n is equal to 1 over 64. Well, before I can do anything else, I know that I need to make this 1 over 64 look like 4 as a power raised to some exponent. So I have 4 to the negative 2n is equal to, in order to make 64 and 4 look the same, I'm going to need to change both of the bases. So the first thing I do is I'm going to move my 64 to the numerator of the fraction by raising it to the power of negative 1. Now, this 4 can be raised to so this 4 to the negative 2n is going to stay, and my 64 becomes 4 cubed raised to the negative first power. So since I'm raising a power to a power, I'm going to need to multiply those exponents together. So this is 4 to the negative 2n equals 4 to the negative 3. And so now that I have two powers equal to each other with the same base, then my exponents are equal, and I solve for the variable. And number 4, we have 25 raised to the 2x minus 2 power is equal to 125. Now in this example, I'm going to have to rewrite both the 25 and the 125 in order to get the same base, because there's no way for me to raise any number to any power, or there's no way for me to raise 25 to any power and make it 125. So I'm going to start by rewriting 25 as 5 squared raised to the 2x minus 2 power, and 125 can be rewritten as 5 cubed. So now I have the same base. Well, when I raise a power to a power, I have to multiply the exponent. So I have 5 to the 4x minus 4 power is equal to 5 cubed, which means 4x minus 4 equals 3, 4x equals 7, and x equals 7 over 4. And then sometimes you have to combine before you ever can solve. So if I have 64 to the 2n minus 2 power times 16 is equal to 16m. Well, I'm going to have to rewrite 64 and both 16s. So 64 is going to become 4 cubed raised to the 2n minus 2 power times 4 squared is equal to 4 squared raised to the m power. So I raise a power to a power, so I have 4 times 6m minus 6 times 4 squared is equal to 4 to the 2m. And when I multiply two powers, I add the exponents. So I have 4 to the 6m minus 6 plus 2 is equal to 4 to the 2m. So simplifying this down a little bit, this gives me 4 to the 6m minus 4 equals 4 to the 2m. And using the one-to-one property, I know that 6m minus 4 is equal to 2m. So negative 4 is equal to negative 4m, and m is equal to 1.